Welcome to New Home Insights, the podcast from John Burns Research Consulting. I'm your host, Dean Worley. If you want to follow market trends, demographics, capital, new ideas, and endeavors that touch on housing, we're going to try to make sense of that every couple of weeks. Let's go. Hi, everyone. I'm Dean Worley for the New Home Insights podcast. We love to bring you innovation in the industry on the show here. Someone doing something different that impacts housing. Today, we're going to talk to someone who is doing something different at kind of a core level, the most core level within the housing sector, and that is building homes. So our guest today is Scott Long. He's the co-founder and CEO of NileBuilt. NileBuilt is a company building net zero homes, and that's cool enough in itself, but their homes are also really durable, amazingly durable. And one of the ways they are is withstanding fire. So we'll talk about that. But first, let's talk to Scott. And Scott, how are things going?
Very well. Thank you for having me today.
Glad you're here. Why don't we start with, we always like to do this. Let's just have a little background, of kind of a brief intro on your background before we start talking about the company.
Sure. So we started, my partner and I started in 1997 to pursue a product line that was first developed by my father back in 1980 that has been used in commercial and industrial applications and is still the predominant leader for what's called sandwich wall panel construction, which is basically insulation in between two layers of concrete. And his background was really in the composites business, and he developed a stronger than steel, yet not thermally conductive connection system that has been used for 43 years now in everything from federal penitentiaries to Home Depots to cold storage units, schools. You can go down the list. I became really fascinated with that in 1997 and started pursuing ways to really reduce the engineering and complexity of these panels to pull them into residential. Developed a technology platform over a few years, and ultimately sold that to Dow Building Materials in 2001. And the product became a licensed application from Dow, whereas Dow would market it under the Styrofoam brand name to producers in the U.S. And we had a tremendous response to it, licensed about a half a dozen U.S. markets. And then the recession came and moved all the parts around for all of us. My partner and I began really pursuing computer automated manufacturing of these parts for commercial and industrial applications in the United States. So we have gone through the goods and bads of centralized factory production. And that really brought us to this new product line, which is a lighter weight, higher R value, higher fire resistant product that can be produced on site, decentralizing a specific location, meaning we can do this anywhere globally through the use of enhanced composite action and fiber composite materials, and have developed and patented this building system and evolved from a product supplier to a builder developer that's really a solutions-based company. And so our primary target right now is Southern California. That has shifted into Houston, Texas. And frankly, those are big enough markets for us right now to get our footing in before we look elsewhere.
So NileBuilt is effectively, you have shifted now to becoming more of a materials company into a builder. Is NileBuilt specifically founded to be a builder?
It was. We struggled like many of the other technology-based companies for the last 20, 25 years to get the attention of the production builders. And it's a very difficult industry to change. We really looked at it and decided that, our moves into the capital markets and the ability to acquire land and design and develop projects is really what we were doing in the first place. So it was a very good transition for us. It gives us a lot of freedom in expression in our architecture and our designs and the overall theme of our developments that we didn't have as a technology or product supplier.
You've kind of touched on a bit, but let's expand on it. But before I talk to you about the inspiration for NileBuilt, let me ask you specifically about the inspiration for the word NileBuilt. It's one word, right? Why?
It is one word.
Why one word?
Why one word? That's a good question. Nile was really kind of conceptual in the Nile River being this strong flowing force. And, it's difficult when you're in this business to focus on any one element of what you do. And so if you focus on energy because it's concrete or strength because it's concrete, a lot of the messaging gets lost. And we were looking really for a more universal name that really defines strength and longevity is really what we were looking for.
Well, I'm glad you didn't do what everybody else does with names of new companies these days, is you have to have like a Q or a Z or a Batman symbol in it for it to be cool. So I'm glad you didn't go that route.
A new word that's made up or misspelled.
Yes, yeah, exactly. Slightly misspelled.
What?
So expand if you could on what was the inspiration specifically for NileBuilt. You found you kind of hitting your head against the wall on making it happen. So you decided to go from a material company into a builder company. Is that kind of the nutshell of what happened?
It's exactly what it is. And I think, as you look at what our designs are and as the public begins to see them, it's a series of different technologies in the assembly process that creates a unique outcome. And so you can turn around and build the most energy efficient building envelope, which is what we do, but selling that as a component to somebody else who's not going to continue that theme, meaning put PV solar system, battery banks, energy efficient windows in it, it really devalues what the product is. And so we looked at it as a more holistic approach that, okay, we have this building technology platform. Now what do we do with it? And when you start looking at wastewater systems and pre-grinding systems for community development, systems are already stressed. If you look at net zero with or without battery banks to not put higher demand on already burdened infrastructure, you look at high wind events and how our roof systems tie in to create, these massively strong structures that will resist wind and moisture drive into the wall to flood resiliency. We have a package that is very universal in the sense that whether I put this home in Orange County, California, or in Houston, Texas, the benefits are equal. But the market demand for each could be different, where people aren't so worried about fires in Houston. They are worried about high wind and water events. And so we found coupling the wall systems with our flooring and roof systems with what we use for high impact glass, for what we use in PV, creates this entire holistic approach to it creates a solution to a market that is vastly different than it was 20 years ago when we had our large build cycle. Politically it's a charged topic, but the realities are the climate events are bigger and worse than they've ever been. And engineering has got to change in the United States for housing to be built, be insured, and C, safely occupied by people. And that was really been our approach from the beginning. Advancing into a builder developer allows us to pull it all together.
It's interesting you say that insured part. You're seeing more in the news that the insured part is a tougher nut to crack recently in some places like Florida, where they're having some very significant home insurance issues there from some of these same kind of forces. So we'll talk more in a minute about the features. In fact, we'll talk about that next. But first, I just wanted to kind of put a bow on that. Is it true that the reason that you're active right now in Southern California and Houston is because kind of the two big pictures that your homes are able to really withstand fire and water? Is it that simple? Is that why you're in those two markets right now?
It in terms of natural disasters, yes. Energy availability is huge, right? And so 20 years ago, we all talked about Energy Star programs and a home that was 10 or 20% more energy efficient. Those days are long gone. The issues now, as we're facing, the estimates in the U.S. are anywhere from, I've seen from 3.5 to 7.5 million homes we're currently behind. Is Southern California as a whole is announcing at least a 2 to 3 million home deficit is a massive load on a very antiquated utility grid. And so those are big drivers for us as well. Also, just logistically, California is a very progressive market, whether people like that or not. Policies happen and it forces change. And, California is the leader in EV cars for a reason, is it was legislated in. We're in the same boat where net zero homes are mandated in California.
Mhm.
All new buildings, I believe 2030 is the target date, are intended to be net zero. And the building technology is nowhere close, to hitting that scale. And so it's a market that we're kind of vacuumed into. Houston has really evolved the same, is that they have a massive need for housing. A lot of people relocating, a lot of corporate environments are relocating into the Texas market. It also happens to conveniently be based where I live in Southern California. My partner lives in Houston, Texas. So as a company getting its footing, it really works well logistically from that standpoint as well.
So let's talk about the home. First, let's focus on that first part, which is the fire. The fire, I don't know if proof is the right word, but that's something that the NileBuilt home is particularly known for. So my understanding is a NileBuilt home is built to withstand over 2,000 degrees Fahrenheit, or even more than that, which I looked it up, and that's the temperature on the surface of the sun, which is insanely hot. And at first, my thought was, gosh, that's super impressive. And then my second thought was, okay, come on, sun, shouldn't you be a lot hotter than that? But are you able really to be 2,000, 2,500 degrees Fahrenheit and a NileBuilt home can withstand that kind of temperature?
Yeah, and so to be careful, fire resistant is the term. There's nothing on planet Earth that I would deem to be fireproof. And so if you look at wood frame construction, which has been around since the 1400s, I believe is the first recorded era or time frame of which dimensional lumber was used, we're still building homes one stick at a time. So the inefficiencies, if you think about it in 2023, just don't even make sense. But the biggest issue behind it is combustibility. Mm-hmm. And so people tend to think that blowing embers are the primary cause for fire spread, and it is to a degree. But the biggest issue is that if the house burning next to you is burning at that 2,000 or 2,500 degree Fahrenheit temperature, which is a recorded temp, commonly understood in the fire service, it takes about 600 degrees Fahrenheit of just combustibility or combustion, heat and combustion to ignite a wood framed wall. Mm-hmm. And so you can see how that dominoes, and these neighborhoods just continue to burn one after the other. And that is simply the fact that you're using combustible materials. If you look at the forestry industry today, there are many areas that are deemed to be too much of a high fire risk to deforest, to pull the lumber out to build a house with. I mean, just think about that concept. The raw materials are too flammable to harvest to go build a home with.
You mean the process of cutting down those trees would be too dangerous of causing a fire, so they can't?
Oh, absolutely. In Northern California, there's forestry areas that are prohibited to the public to access.
Oh.
And so, this is what we're dealing with. And so if you look at a change in materials, and in our particular case, concrete, everybody understands does not burn. But what you have to have is thermally efficient concrete as well. And so in our particular design, we have encapsulated XPS, or an extruded foam board in the center core, which is 4 inches, which produces a massively high static R value. But the importance of that is making sure that there is nowhere that fire can penetrate through the concrete layers that are around the foam. And that is a function of using fiber composite materials, which is a proprietary blend that we have to encapsulate this foam core so that it cannot be accessed by fire. Now, back in the 80s and 90s, my father first did what we called a kiln door test. They literally took a ceramic kiln to fire ceramic pots in and built a door out of this material. And they fired it to 2,500 degrees for 4 hours. And obviously the inside of that kiln door was 2,500 degrees. The outside, I believe, did not exceed 120 degrees.
Wait, I want to make sure I understand you right. You mean they made the door out of the material that the kiln is made from?
No, they made the door out of the material that we build homes with.
Okay, gotcha. Okay.
And so what happens is that the foam does shrink in the wall, and it creates an air void, and that air void traps the thermal transfer, heat transfer through the wall. So in a situation where one of our homes takes a direct hit with fire, it's very likely from a life safety standpoint and a personal property standpoint that it'll survive that. If you are dealing with something with a direct exposure of 2,000 degrees for hours on end, we certainly wouldn't, overstate the fact that the home would not be damaged. But that's a far cry from the combustibility at 600 degrees and losing the entire structure.
So if there's a fire next to you, let's say in your now built home, what happens? Your next door neighbor, tragically, terribly, their house has caught fire. What do you evacuate, you get out of there because otherwise your home is an oven, but you leave. And then what happens what happens to the material? Material just resisted? Is there any other process that happens when the fire starts? It's just that your home is built, is going to resist that fire.
It's going to resist it. It's going to resist combustibility. And so the thing that has the greatest likelihood of igniting the home is just not a principle that's going to occur. Now, there are a number of fire curtains systems that are on the market now to cover windows. And in areas where we're in severe high-risk fire zone properties, those will get installed on our particular buildings. So just imagine that if you knew the fire was coming, you could activate kind of like a shutter system in Florida for hurricanes and protect the window systems as well. This is a huge issue. I mean, you look at all of the homes in this particular market and the population here, I don't know of anybody that doesn't have a bag packed, for a fire. They're just waiting for it to happen. And so it's not, the fire protection curtain systems are certainly not a standard installed device on every home, but in the areas where it's either desired by the client or it just makes sense to get code approvals, those would be installed on these homes as well.
Okay, that's kind of what I was thinking in my head was asking that question, is do shutters come down as the fire is detected or something like that and add protection? Do you have fire sensors on your homes?
Yeah, these actually have thermal sensors on them, so they can be electronically triggered via mobile application, or you can just let the exterior sensor determine it, and it will deploy the fire curtains over the windows and doors.
Okay.
So that is a home that is going to have the highest, potential of surviving a direct fire hit.
Yeah. But that's not all. For the fire resistance is not the only thing going. You also have, let's talk about some of the other aspects of your homes. So let's start with sound absorption. They're naturally highly sound absorbing or sound resistant as well.
Yeah, so it's an STC rating, or sound transmission coefficient, is right around 55, which is to be expected with concrete. And in our case, it's a little higher with the foam core insulation. But what's interesting in living in these homes is that you just don't hear what you normally hear in a wood frame home. And because of that, many of the people that have lived in these homes just refuse to move. So you don't hear the neighbors talking. You don't hear cars going by. You don't hear the garbage truck. When a door closes on the outside of the home, the house doesn't shake or rattle. Wind blowing against the home, the creaking that you commonly hear in a wood frame home disappears. It's just a solid, quieter, safer, place to live.
Your windows aren't, you would have the normal sort of dual pane windows that other homes would have, though, in terms of that sound absorbency, though. Correct? Or is it?
Correct. And so, but you'd be surprised at how much wall surface area is wood framed with fiberglass insulation in it that just, it does very little to dampen sound, in those walls. And again, it's just acoustically, it's a whole different experience for the occupant.
So there's fire, there's sound, there is also the energy aspect and the efficiency aspect as well, right? I mean, you are building net zero, no carbon footprint homes?
Yeah, in most cases. And so, in California, the gas is getting pulled. It's going to be prohibited in new home construction. And that's really the only carbon outputs that you would have in these types of homes. But to be specific about it, the reason these homes perform so well at net zero is the utilization of the thermal mass of the heavy concrete in the walls and floors. And so in a typical 2,500 square foot home that we produce, between walls and roof, you can have anywhere from 100 to roughly 200 tons of concrete thermal mass. And that thermal mass is a known phenomena in physics, stores and retains and re-releases energy. And that is the beginnings of getting to net zero. And many of the other things that have occurred in the last 20 years have been all of the LED bulbs and high efficiency appliances. But the predominant issue to getting to net zero for energy consumption is your HVAC consumption. And light gauge framing, whether it be metal or wood, is not feasible in terms of the kW that you have to produce with a solar system to get it to net zero. And that's one of the areas that wood frame builders are really struggling with today. For us, we did the first study in 2007 with the Department of Energy and Nevada Power and for a couple of firms out of California, all sponsored by the USGBC. And we did a test between one of our homes and a wood framed home where they would close up all of the windows and doors at sunrise, let me back that up. In the evening, they would close the home up and they would condition it in the evening hours. In the morning, they turned off all the HVAC systems on the homes and measured the number of degrees and temperature each home went up between sunrise and sunset. The wood frame homes went up roughly 12 to 17 degrees. Our home went up 3.5 degrees. Wow. Proving that you can move the cooling to off-peak periods of time, which power companies love. So in the nighttime, you cool the home, you seal it up during the day. In our particular case, the home rose 3.5 degrees in temperature. That allows us to generate all that energy during the day and through net zero metering, put it back on the grid. And at the nighttime, we pull back off of it. The homes that we did in 2007 have been off grid for 16 years now. We've even stopped to talk to the homeowners, and they provided us copies of the utility bills. They've never paid more than a $10.50 per month utility hookup for 15, 16 years living in these homes in the desert.
And that's in the height of summer where most people's AC is going.
Oh yeah, $400 to $600 a month bills are normal, and so that's a huge issue. But we pioneered that study back in 2007, and that's the data that we use to calculate solar kW against the thermal mass benefits of what we do in our building system.
And your homes are going to be energy storage units effectively as well, right? Are they mostly solar, and you have a battery that stores energy, and that's why they're able to be off the grid, or how does that work?
Typically, we don't need the battery to get to net zero because of the low use during the day and power generation we put on the grid. The battery backups for us are really more of an issue for storms and power loss. Wow. So that's an optional feature in many of the homes. But unlike the light gauge wood framed homes where they're trying to generate energy, put it in a battery and reuse it, we circumvent that entire expense and process.
And you're also smart homes, right? Everything has to be a smart home these days, and everything mostly is a smart home. And smart home technology has grown exponentially this last decade or so. What is it specifically that you build in that makes your smart home smart?
Well, our technology focus is really more on the building envelope and the overall performance of the home. You have the ancillary items that you can buy at Best Buy, the Nest thermostats, and you have data tracking, and there's a number of products that are in development or in the early commercialization stage. There are things like smart circuit board systems. Imagine monitoring those from your phone as opposed to a flip switch. And those are features that we put in the homes. And I think those are expectations by consumers. It troubles me when I walk through a $1 million or $1.5 million condo and they have a $19 thermostat hanging off the wall. And you have, a demographic in the 20s and 30s and even 40s or older who are just accustomed to having Wi-Fi technology everywhere. Yeah. So I find it a shame that it's not just more commonly used in frankly, everything that's built in as opposed to being an upgrade of some sort.
It is tough for builders to keep up with that because what is an innovation at one point very quickly now becomes an expectation. And that's for sure. Consumers these days are very expectant of the smartest of smart technology. And it's not, you're right. It's not an add-on anymore. It's a must-have.
Well said. Well said.
How about, now I know people out there right now, I imagine they're screaming and saying, okay, but what about the look? What about, are you doing for lack of a better term, modern architecture, will a NileBuilt home more or less look like their neighbor's stick-built home?
We have a very unique style of modern architecture, and it both serves as kind of the overall aesthetic and theme of the home that we want, but it also serves a structural issue for us as well, which is you'll notice in all of our designs flat roof systems, and that's because we use a metal bar joist and a concrete top coat for fire resistance and for a structurally rigid diaphragm, whether it be high wind or seismic. Everything has a functional purpose in our particular case. And we want that theme. We want our neighborhoods to be ones that when you drive by, it catches your eye in a different light than traditional stucco and tile building that has been, a dominant architectural force in the United States for a long time. Interestingly, in our southern markets here, modern architecture has really taken off. So by the time we really came to the design table, we already started seeing it as really a solid design trend. I was very surprised to see Houston has adopted it as much as they have. Almost every new home that we see is, a very, bright colored, dark contrasted windows, large windows, and flat roof lines. And so that for us is not only, an intended marketing aesthetic, but it's also a purpose of functionality.
Okay. Let's talk about the process then. You are effectively an off-site panel construction builder. Is that fair to say? And maybe walk us through how these homes get built.
Sure. And so what we worked after 10 long years in the computer automated factory business is where a lot of the investment dollars are going today is in modular. And we've been there. And we've gone through that learning cycle that many firms are just entering into. And it is a very, very, very difficult business to be in. So you have a centralized production, you have a tremendous amount of computer automation, sensors, lasers, a lot of things that can break to put under one roof. A lot of logistics issues and cost and loading everything up, hauling it out to a job site. There's a skill set that is needed in these types of factories that just simply doesn't exist in the United States. And so, simple question for it is the guy who knows how to swing the hammer running the computers, or is a guy who knows how to run the computer swinging the hammer? And they're two different skill sets. And it's a very difficult area for procuring employment. We've designed this product to be produced on job sites. And so since our business is very centric around volume production, very simply put on a, roughly 50 acre, 10 acre, doesn't matter the size parcel, we will set up a small production area on site. We have a series of molds, or what are called jigs, that are used for each panel for each particular model floor plan, and those products are poured on site. And because of the lightweight nature of the product, we can actually move them down the street via front end loader or high tonnage forklift, and they're set in place. And so we completely eliminated all of that capital expenditure and freight logistics associated with modular. So we've kind of created a space that doesn't exist. They are prefabricated parts, but they're not modular. We don't have real rigidity, meaning you can only make things one way. And so it's kind of the best of all construction techniques is what we put together. And what we focus on is what we call process improvement. How do you look at the different aspects of construction and blend them together with a new material to create a unique outcome?
Yeah, it's kind of hybrid, isn't it? I'm realizing as I'm listening to you that it's sort of like offsite construction in the sense of making it, but you've wedded that with onsite construction because that's where you're actually putting it together. That's interesting.
It is. It's a segment that I don't think we would have found our way to that path without going through the centralized manufacturing process.
What is the tech? Well, you've kind of explained a little bit earlier, but maybe just remind us the tech that makes you net zero. You explained the fire resistance a bit ago. What is it that makes you net zero other than that is just the concrete, is the natural insulation powers of concrete? Is that?
It's a combination. So with a 4-inch XPS or extruded foam core, we have a static R value of 20. Which is unheard of. So if you take a wood framed wall and you stick a R19 bat in it, and then you account for thermal bridging of each stud, moisture drive through the wall. They truly perform at about an R9 to R11 if you put that wall under load. We're a true static R20, meaning, there's no thermal breaks, there's no conductivity through the wall. But the bigger issue in conjunction with that is the interior concrete mass of the wall system itself stores and re-releases energy. And we call that a thermal battery. And so back to the points of cooling the homes at night and sealing them up during the day is 100 tons of concrete thermal mass will store an awful lot of energy for an awfully long period of time. It's the combination of those two elements that reduces the amount of kW necessary to produce by solar. So, for example, and I failed to mention prior, the net zero homes that we did as part of the USGBC and Department of Energy study only had a 5 kW system on it. It's very inexpensive. That's 4 panels roughly on a home.
Four solar panels to create those 5 kilowatts. Is that what you mean?
Right. And that's enough to power these homes and create a net zero energy result. You won't see that in a stick framed home where they're running 4 to 6 ton air conditioning units. It just, the power consumption is too great to be offset that greatly by a PV system that's affordable.
What are the costs? So there's a certain group of people listening and saying, okay, what do they look like? There's another different group without a lot of overlap probably that are thinking, how much do they cost? Are you gaining a hard construction cost advantage over stick built? Do you have any sense of what that might be?
Oh, certainly. It's our construction costs are in line with any wood frame construction in the United States in any of the markets. We don't have the fluctuation of materials. The raw materials that we use tend to fluctuate in the single digit percentages, which makes it very viable for us where wood has gone up 1,000%. We have designed the product itself to require a moderate level of training to be able to produce these wall panel elements on site. Makes our labor available, which is very difficult to find skilled carpenters these days. And I want to stress the only wood used in any NileBuilt home is for decorative purposes. There is no structural elements in the homes whatsoever. But our market to market costs are consistent with what's out there with wood frame, only the value behind the homes is much greater and the operating costs are much lower. And we see that as a way to attract a lot of clients our direction. We also have a very, very strong emphasis on the affordable housing space. This is very frustrating to me to see the low number of actual home ownership in the United States and to see it continually dwindle. One of our primary targets is public-private land partnerships, and we're working on many of those throughout California and Texas right now to be able to build in volume homes that fit within the affordable housing indices per zip code, and those are published, I believe, quarterly. It's just doesn't seem to be something that the current building infrastructure out there really is that interested in. Our goal is to help people get out of apartments and get into homeownership. So we have a series of what we call villas that start at 1,000 square feet and go up to 2,500 square feet. It has all of the nuances of any of the higher end homes, meaning it's net zero, non-combustible, durable, has a beautiful architectural design to it, yet just simply a smaller footprint that puts people in line with a mortgage payment that would be consistent to a rent payment in that particular market. It's a huge area of emphasis from a business perspective of what we're trying to accomplish.
Is there replicability in your homes? Are you kind of tied to geographically being near one of your centers where you are making these materials, or could you, would you truck it? Could you be almost anywhere, or do you kind of need to be in Southern California, Houston right now because that's where your plants
No, we can set up our production area on any job site, and so in an area where we would set up to produce the wall panel elements, and as I said, forklift them down or front end load them down the street to each respective job site. We can do that anywhere, and so it allows us the mobility to expand, nationally or globally without having all of this capital infrastructure expenses that modular is facing right now.
I'm going to ask you, Scott, to be your own devil's advocate. What is the biggest downside of a NileBuilt versus a stick built?
That is a really great question. I mean, we've worked very, very hard over the last 2.5 decades to pull any of those negatives out of it. Of course, anybody in my position is going to be biased by saying nothing.
Yeah.
But, if you look at it from an aesthetic standpoint, they're beautiful homes. If you look at it from longevity, it's far surpasses wood framed homes. We have a history of building these homes for 25 years along with commercial buildings. And we have a very happy client base. I think for us, the big challenge now is hitting the capital markets to build the balance sheet we need to start building at scale, which is the 1,000 to 5,000 home developments that are in demand and not beneath that. But yeah, I'd have a hard time really telling anybody truthfully that there is a disadvantage to living in this type of construction. I think it's badly needed in the United States. And if you look at where we are in 2023 from a technology standpoint socially, housing has not evolved ever. It is one of the last industries that's just still doing things the way it was done hundreds of years ago. And I think people were okay with that because there weren't other known solutions. And I think the industry is suffering from that lack of technology implementation is really biting the industry in terms of materials and labor and code approvals to get permits to be able to continue to build the way they used to.
Yes, we have fewer moats and crenellation, but otherwise, yeah, it's similar to the way it was a long time ago. My gut says in terms of the aesthetics, you might have, there are just going to be some subset of folks who don't like flat roofs. And in terms of market too, you might find, are there going to be some snowy climates, for instance, that are going to need those sloped roofs for snow buildup, things like that?
Yeah, and that's a good point. I mean, our primary target is in the southern states right now. If we do work our way back into the Midwest, we can certainly engineer for those markets. But the product line that we have now is really is designed for the southern markets.
Okay, let's wrap this up with about the future. You right now, are you mostly custom? Are you going to be getting into production builds in a big way? Is that the idea?
Yeah, and so it's a little bit of both. Right now, we've got a catalog that will be available on our website here shortly of 12 model homes that range from 1,000 to 5,200 square feet. We are building a digital platform for ordering. So, for example, when we launch a development, a consumer experience will be much different than what is the norm today, which is to be able to go into that development, pick your parcel, pick your floor plan, pick your amenities, and put it in the basket to check out. And that will initiate a pre-approval financing process for us with one of those 12 current floor plans. We will continue to expand to that. But right now, the primary market that we're seeing is the 1,000 to 2,500 square foot homes is where the massive demand is built up in the marketplace.
Are you able to build in some places because of your fire resistance and some other aspects of your homes that it's tougher for other builders to be able to go to right now?
Oh, absolutely. Particularly in California with the redrawing of by the fire authority, the high-risk fire zones. So it is prohibited in many areas now in the state of California to be able to build out of wood in these high-risk fire zones. And we are actively working with the fire authorities and municipalities to look at our community designs, which is not only, the non-combustibility of the homes, but the things that are being required by the fire authorities for fire-resistant landscaping and keeping what they call fuel or basically just dry brush away from homes has opened up a huge opportunity for us in these markets that want to expand. It's just either the municipality won't allow it and or insurance companies will not have anything to do with it in those particular markets. That gives us access to a lot of affordable land, and it really helps steer us down that affordable housing path that other builders are simply not going to be able to do.
Well, what you're doing sort of drives some other folks to look into similar technologies and similar solutions.
Well, they are, and there's literally billions of dollars being invested in this space right now into things like 3D printing and pre-assembled metal walls and unfoldable houses. In my opinion, I think the reason those dollars are so high is because the problem is so vastly large. And this is a multi-trillion-dollar problem for builders collectively in the United States who are not currently able to build in many of these markets. And so, yeah, it's going to drive alternative construction methodology that is going to need to be designed and engineered and brought through a code approval process to shift gears out of this very outmoded wood-framed mindset. And so we definitely see more of those systems coming online, and we certainly aren't advocating that we are the nation's only solution to the housing crisis. We feel very confident that we are one of those and can make a very significant social impact with what we're doing.
Awesome. Scott, thank you so much for coming on the show. I really appreciate it.
Thank you very much for having me.
This is Dean Worley for the New Home Insights podcast. Thanks so much for listening. We'll pick it up again in a couple of weeks.